Hey guys, today we're starting target 7a, which is properties of polynomials. So let's look at some of our vocabulary. We've talked about a term before. A term is just a number, variable, or a product of numbers and variables, so multiplying together. So the number 4 could be a term, but also like 4x squared is a term. So it has variables in there, it's still a term. Polynomials, any set of monomials, which are also terms, added together. So again, a polynomial is just terms separated by addition or subtraction signs. For a degree, the degree of a term is the value of the exponent on the variable, right? So a term itself has a degree where it's just whatever the exponent is. The degree of a polynomial is the highest exponent value in that polynomial, right? So a polynomial has many terms. Whichever one is the highest, that's the degree of the polynomial. Today we're really going to talk about end behavior. End behavior is the behaviors of the graph as x approaches infinity or negative infinity. Infinity is just what's it doing as it goes to the right. Negative infinity is what is it doing as it goes to the left. Domain is all possible x values of a function, and range is all possible y values of a function. Okay? So let's look at some examples. Example 1. Oops, that's one. Determine the degree. Determine the degree of the polynomials. Negative 10k to the fourth plus k squared minus k. For these examples, all we're looking for is the largest exponent. Okay? So looking at A, my largest exponent is 4, so that's a 4th degree polynomial. Looking at B, again, my largest exponent here is 4, so it's a 4th degree polynomial. Looking at C, my largest exponent is 2, so it's a 2nd degree polynomial. And that's it. Right? So those are super simple, just looking for that largest exponent. Looking at end behavior. Now we use the degree of the graph to help us with the end behavior, right? So if the degree is even or if the degree is odd, that's going to change the end behavior. The other thing that affects the end behavior is if the coefficient in front of that is positive or negative. And like in this example, it's negative, right? That's negative 10. Here it's negative 5. Here it's negative 2. Actually, all three of these are negatives. You can also have positive ones. Those are the two things that affect your end behavior. And that's it. We really only have 4 different types of end behavior for polynomials. So let's look at our 4 different types. If you have a positive coefficient and an even degree, your graph is going to look something like this. Okay? This part in the middle can change. It can move up and down all around. It's the ends that are always going to look like this. They're always both going to be going up if it's even and positive. Then when we write what the end behavior is, we have a very specific notation called limit notation. Okay? I'm going to start with going to the left. Right here, I'm going to start on the left side of my graph. So with my limit notation, I'm going to say the limit, which is abbreviated LIM, and underneath that, I say what x does. X is going towards the left. That means it's going towards negative numbers, so negative infinity. Once I say what x does, I need to say what y does. So y, instead of saying y, we say f of x equals, and when I look at my graph is going up. Up is positive numbers, so it's going towards positive infinity. So the limit as x approaches negative infinity of f of x equals infinity. Then I need to do the other side of my graph. Now I need to go to the right side. So same type of thing. The limit as x approaches going to the right is positive infinity of f of x equals, now my graph is still going up. Up is also positive, so that's just positive infinity. And that's it. Those are my 2 things I have to write for the end behavior. You have two sets of limit notation, as x approaches negative infinity and x approaches positive infinity. Let's go ahead and look at our next one, right? So this is a positive but odd degree function. It will look something like this. And again, this middle part can do whatever. That middle part doesn't matter. It's just the ends that matter. So again, I'm going to start by going to the left. The limit as x approaches the left is negative, so negative infinity, of f of x. And then my graph is going down. So that's going to be negative infinity. As I go to the right, I have the limit. And underneath it, as x approaches to the right is positive, so positive infinity. And then my graph is going up. So f of x is equaling infinity, positive. So it's going up is positive numbers. Our next one is the graph it's negative, but it's an even degree. So negative and even. The negatives really just flips the positives over. So it's going to look like this. Again, this middle part can be whatever it wants. The ends are what matters. So the limit as x approaches, we're going to do the left first. So to the left is negative. F of x is going down. So that's negative. When I do the right side of my graph, the limit as x approaches, right, going to the right is positive. F of x equals, my graph is going down, that's negative infinity. Alright, our last one is negative and odd. Your graph will look something like this. Again, it kind of just splits that graph. Again, the middle part can do whatever it wants. It doesn't really matter what that looks like. So if I go to the left, the limit as x approaches, left is negative numbers, so negative infinity, of f of x equals up. Up is positive, so positive infinity. As I go to the right, the limit as x approaches, the right is positive numbers, so positive infinity. My graph is going down. Down is negative numbers, so negative infinity. Okay? And that's it. That is all the different types of end behavior you can have for polynomial functions. If you look at other types of functions, there are some different things, but for polynomial functions, that is it. All right, so let's look at an example. Go ahead and turn to the next page. So, looking at example 2 says determine the end behavior of the function and write in limit notation. Okay? So again, I'm going to start by going to the to the left, not the right. So, like before, this is the limit as x approaches. It's going to the left, and left is negative infinity, of f of x equals, and then my graph is going up. Up is positive, so it's infinity. Then I need to go to the right. The limit as x approaches to the right is infinity of f of x equals, on the right my graph is going down, so it equals negative infinity. Yeah. Just like before. Easy peasy. Alright, looking at our next example, same thing. I'm going to start by going to the left. The limit as x approaches left is negative, so negative infinity of f of x equals, and it starts by it's going up there, so it's just infinity. Then the limit as x approaches the right is positive number, so positive infinity of f of x equals, and on the right my graph is going up, so it equals infinity. Done there. Okay. We're going to skip C and D. We're not going to worry about those ones. We're just going to look at when we have a graph. So we can go ahead and cross those out. Then let's go ahead and look at example 3. So we're done with end behavior. Now we're going to look at domain and range. Domain and range are our x values and our y values. Okay? So we're going to start with our domain. Domain is anything x can be. So if I look at this graph for my domain, I want to think about what can't x be. Okay? Well, these graphs all have arrows at the end. Don't ever forget that. Even if they're not there, they're invisibly there. Okay, all these graphs continue going forever. They don't just stop because we can't see them anymore. So for our domain, for our possible x values, this graph is going to continue up and to the left a little bit forever. This is going to continue up and to the right forever. So where does it start on the left and where does it stop on the right? Technically, it never does. So we just say negative infinity to infinity. It starts at negative infinity and it goes to infinity because it never actually stops. Okay. A little hint is that all polynomial functions start at negative infinity and go to infinity. That's always going to be our domain. Always. So if you ever see it on a test or a quiz, what's the domain of this polynomial function? We should always know it's negative infinity to infinity. Okay. Our range is different. Our range is not always the same. But it's the same type of idea. For range, it's our y value. So I'm looking going like up and down. So I want to think about, okay, where do I start? And we always start at negative numbers and go towards positive numbers. So we're always going to start at the bottom and go up. So I'm going to look at the bottom and see where my lowest point is. And my lowest point, right, never crosses, think of it like a fence, right? It never crosses that fence. So the lowest value it can be is that -4. With notation, anytime you have a number, you put a bracket around it. Anytime you have an infinity symbol, you put a parentheses. It's the same going from negative infinity to infinity. For my range, it's -4, 2, right? And then we'll go, okay, how far up do I get? Well, this graph, again, it continues up forever in both directions. It doesn't stop going up, and up is positive. So it goes up to positive infinity. Okay. Let's look at B. My domain, a little bit more notation again. Again, my domain never stops. So we put it in this, we call it interval notation. Okay, it's with parentheses, it almost looks like you're writing a point. You're not, but it's kind of the same notation as a point. I'm going from negative infinity to infinity. For my range for this one, I want to think, okay, where do I start at the bottom? Well, I go all the way down. I keep going down. So technically I start at negative infinity. Okay? Then where do I stop? When do I stop going up? I don't. This goes up forever. So infinity. So if those arrows are pointing in different directions, your range is negative infinity to infinity. And again, with parentheses, with infinity signs, you always have the parentheses. The numbers have what we call brackets. They're square brackets. All right, let's look at C. For C, our domain, just like before, is negative infinity to infinity. Always, always, always. Because again, it never starts, it never stops. Okay. Our range, right? Again, where do I start? At the bottom, right? Well, these both go down forever. So I don't really start anywhere since it's going down forever. It's going to be negative infinity. When do I stop going up? Well, my highest point is right here, right? Again, it's a fence. There's nothing beyond that. I can mark a point where there's nothing beyond it. Okay? So that stops at 3. And again, that would be a square bracket. All right, looking at D, last one. The domain, again, is negative infinity to infinity. Your graph is going to go on left and right forever. For my range, starting at its lowest point. It does have a lowest point. I can draw a fence underneath it. My lowest point, it looks to be about 2. My line rule curve. We'll say starts at -2. Again, since it's a number, it's a square bracket. And then where does my graph stop going up? It doesn't stop going up, right? So it's going up towards positive infinity. So -2 to infinity. And that's it for domain and range. So the two things we looked at today were end behavior and domain and range. And that's it for today. I will see you guys tomorrow.